We have 4 p.m. Let's get started. Hey everybody, welcome to today's stream. Today we are going to talk about learning Apache Spark. I have Philip here who created a roadmap. He is an experienced developer and freelancer for working with Spark, and he also teaches Spark in his own program. So let's get started. Let me bring in Philip. Hey, Philip.
Hey, Andreas. How are you doing?
Yeah, good. You?
Yeah, fine.
All right. Yeah, before we start, Philip, one more thing for everybody in the chat. If you have any question, put the questions in the chat. We have either, if it fits directly, we can answer it directly, or we're going to then answer it in the Q&A session. And we're going to start with talking about why Spark is so important, right, Philip?
Yes.
And then we're going to talk about your roadmap, and then we'll do a Q&A. So, Philip.
Sounds like a good plan.
So, Spark, I also worked a lot with Spark, and I just saw that some people were on Instagram. Somebody asked me like, what is a platform for processing a lot of data, and that for them it feels like Spark is the only thing. So, is Spark that important, and why is Spark so important?
Yeah, that's actually an interesting question. So, Spark is actually used for processing large amounts of data, and it's a distributed processing engine, which makes it quite unique. So, actually, it's used together with data lakes, which can store large amounts of data in file format. And we use Spark as the processing engine on top of that. So it doesn't provide storage capabilities, it's only processing. And actually, we are writing SQL-like code to tell the framework what we would like to do with the code, with the data. And that makes it actually quite interesting or quite unique in this entire space. And then there are platforms as well, like Snowflake or Databricks, which actually build an entire product out of having Spark for processing data from a data lake. So, yeah.
So would you say people start with Spark and then get into Databricks because that's the natural progression, or could people also go directly into Databricks?
You can go directly to Databricks. However, I would recommend everyone, or I myself are a fan of writing code in an IDE, learning to set it up oneself, because Databricks is just one tool which we can use. So if you are a data engineer looking for a new job and you only know Databricks, you may have some trouble finding a job because other companies may have a different development setup or data platform developed themselves. So you are more flexible if you know how to set up Spark yourself and know how to write code. And all of that knowledge, on the other hand, transfers to Databricks as well. So once you know Spark, you can use Databricks out of the box. So
you said to me that with some students, you actually, because they had problems installing Spark, you used Databricks in the beginning with them, right?
Yeah, if someone would like to start with Databricks, the entry barrier is lower. However, as a small, promotion, I have another live event going on tonight at 6 p.m. Central European Time, where we start with Spark and Python, so PySpark, from scratch, and we are going to set up a project in an IDE. And we will probably get this done in 5 minutes. So the entry barrier on Databricks is lower. However, creating the account in Databricks probably takes the same amount of time as setting Spark up on your local laptop once you know what to do. So it depends on the student.
Where's that event? Is that also on YouTube or on your LinkedIn, or both?
That's on LinkedIn.
Okay, on LinkedIn. So everybody, find Philip on LinkedIn, and then if you're interested in that coding part, take a look.
Yeah, let's
Or
get these hands dirty.
it's the thing is, if you want to learn it, you need to get your hands dirty, like I said, right? And you need to
Exactly.
just start doing it. There's actually a question I found that interesting. Is Ibrahim asks, is ClickHouse killing Spark?
Wow, I have no idea. I have no idea.
Okay.
I actually not so familiar with ClickHouse and how vastly it is adopted, and but for now, I mean, there are usually evolving new platforms, but once, I mean, if you think of 10 years, maybe, but many companies have their setup, they have their clusters, they have their development routines, they have a lot of code in Spark already. So they are not even done with transitioning from a data warehouse to Spark. So there will be jobs in the future. I don't know what's going to be there in 10 years when they transition from Spark to something else. But for now, it's very, very important skill.
Yeah, that's true. Serum here had a question. Databricks solves the problem of managing the infrastructure. Can you please explain that infrastructure? I'm guessing in detail. I think that's in your roadmap, right? A bit like
As well, yeah.
as well. Yeah. Also, yeah. There are already coming a lot of questions in, and I'm looking at them, and I want to ask you everything. One thing. So before we get into the roadmap, Spark is not meant for real time, right? Whereas ClickHouse is mostly for real time streaming. So real time and Spark. What are you saying?
Yeah, I mean, I've been working on a large project, and of course, there's a whole bunch of technologies for processing real-time data. And in this particular one, we were using Spark structured streaming, which works fine as well. I have used Kafka streams as well to some extent, and structured streaming in Spark. I think both of them are very good technologies for doing so. It's a good question, which if there's any benefit for any other technology, but I have made very good experiences with structured streaming.
I feel like sometimes people think that Spark isn't real streaming, because I get the topic all the time, like, they're doing micro batching and they're not doing real streaming. Like,
yeah. I mean, they have added support for real streaming in a sense, but how many use cases do you have where you have this second, where the second counts? I mean, for most of the analytics part, and we are talking about analytics platforms here. So I wouldn't probably there are better technologies for a transactional platform, so for transactional data processing. But in analytics platforms, I would say 5-10 minutes usually. So if you really look at the use case, it's sufficient.
Yeah. By the way, Philip, when you look at your image here with our streaming setup, is your picture smooth or your video smooth? How you see yourself? Is that smooth? Because I feel like here it's on my end, it's not smooth. Are you seeing? Is that just a bug on my side? Are you seeing, like, is Philip's video smooth, or is this choppy like for me? For you, please do me a favor and put a small comment in the chat. Yeah, should we get into the roadmap?
Yeah, Philip? Why not? Let's start. Right.
Let me get it up here.
Looks like the video is good.
Yeah, and then just send us through everything. All right, it's smooth. Okay, then that's a visual bug here on my side.
Okay. So I've created this roadmap because I teach Spark actually, and first of all, there's a small that's related to the question we had before. Why is Spark so important? I used to use a small picture here showing that we use Spark in many forms in a data platform. But we can come back to that if that interests you. But for now, I would just go as said with the roadmap. So I'm teaching Spark, and I've come up with this rather high-level roadmap, which I find is the optimal way of learning Spark. So I guess some of you or most of you are here because they're trying to learn Spark. And I think, or I feel that it can be quite overwhelming or frustrating if you don't know where to start and how to proceed, because there's actually so much information out there, so many tutorials and blog posts and all that information which you need to process. So it may be easy that you lose track from time to time. And therefore, I would like to encourage everyone to just sit down and ask yourself what you would like to learn. So what it is, where you are standing, and what would be a reasonable next step. And for the guidance, I created this roadmap here. So, and if I'm working with students who don't have any experience or knowledge, I start with the Spark SQL API. That would be part 1 here in the top left corner, where we simply get familiar with the API, how to use it, which language would you like to use, relating to the question from before, which development setup would you like to use? Is it Databricks or on your local laptop, and so on? So all of these questions. Then to get some data that you can work with, and there are quite some good resources. For example, on Kaggle, there are already pre-processed and prepared data sets which you can use, which have been prepared for use cases like that. So you don't have to waste too much time cleaning everything up, but you can use them right out of the box. So just download some data set that interests you and get to work building a small application. In the end, maybe an entire project, maybe add some configuration. And here, it's also important, yes?
The data set, do you have some that you, or some types that you like? Is it more, or that you recommend? Is it more time series, or is that more something like another domain? Like, what would you recommend people to use first?
So usually, as I will do in the live stream later, my favorite data set is the stock market data set, which is on Kaggle. Okay. It's a very simple data set. You can choose from thousands of stock data, so stock symbols, and usually I only use 1 or 2, just to get some use cases in place. So I usually use that one.
Okay. It's funny because my favorite data set, and that's also on Kaggle, that's from an online retail store.
Okay.
Where people make purchases and then sending this through in a stream. Is also a nice way.
That sounds interesting. I think there are more joins. So what I'm missing on my stock markets data set is there you can only do a couple of useful joins actually. Also retail is interesting because later on here in part 4 of performance, we would like to have some data which has real world distribution, but the stock market data set has actually 1 data point for each day, which is quite uniquely distributed then. So the retail data set may be beneficial if once we would like to debug performance and so on. So
okay, so that the part 1 set everything up, select the language, get some data, and then let's go.
Maybe one more important step. Write a test or a couple of tests. Okay. Write some use case, define how it's supposed to behave, and write some tests. That will be very important. Also, what I would like to add here in part 1 is we work with very small data sets. So 1 file of a couple of megabytes is enough. We just want to execute quickly. We just want to familiarize ourselves with the API. Anyway, moving on, part 2, studying the internals. I have my set of internals which I like to teach because they teach a very, very good understanding of how the framework works. So so if you are learning Spark, I would suggest you to look at how is parallelism achieved, and probably all of you know that already. But it may be interesting to look at MapReduce as well. There's a paper, and Spark is heavily built on top of the idea of that. Also partitioning, which relates to parallelism. What's an RDD? What's a data frame? What are the differences? How do SQL queries get optimized by the catalyst? All of these are very interesting questions. And if you are, maybe that's the hardest part of studying Spark, because there are so many things and one gets really easily like pulled in any direction. Just pick one topic and research it for a week or something. So you will find a lot of information. It's best to have a specific question in mind if you're trying to learn anything. And that's what I would work with students here in part 2 as well. Now then, part 3 would be real-world Spark, which probably relates to the question we had before. In part 3, we would like to work with Spark applications as we would do it in a professional setup. So if you have a data engineering position where we are a Spark engineer, how do we deploy applications to real clusters so that they run distributedly? How do we deliver configuration in such real-world scenarios? And how do we monitor running applications on a cluster? And these 3 steps, so part 1, 2, and 3, actually form the foundation for part 4, which is the performance optimization. That's what usually people are most interested in. I like to tell my students that once the first 3 parts are understood or well understood, part 4 actually becomes quite from itself in a sense. So once we understand the internals and once we can monitor the application, we can detect the common performance bottlenecks there are. And of course, we have to know these patterns, and usually these performance problems follow specific patterns. For example, as I mentioned before, a skewed data set, which is the case in most real-world data sets, will yield some performance problems. And then we will have to look at how can we mitigate such bottlenecks, and that we do in part 4. Therefore, I would recommend anyone to use a data set which has a skew or something like that. Or you can also use synthetic data to basically simulate one of the performance bottlenecks. So there are some. So I think there's a summarization of performance problems, which is called the 5 S's. So there are 5 problems starting with S. And you can basically simulate all of them with synthetic data and try to mitigate them for yourself. Mm-hmm. And that's what I would do in part 4, also when I teach Spark.
Can you give us a quick preview? What are the S's?
So the first one is the data skew, which is the most common one, I would say. So you have, for example, a retail store, and 90% of the orders are made by 3% of the customers. And then there are 10% of the orders made by 97% of the customers. And then you join them for some sense, and then one of the partition becomes very large. And that task will take forever, or will take like 10 times as long as all of the other tasks, and you will have to break them down. Then we have data skew. Not skew. We have small files problem. I think that's one of the S's. So you have many small files which are not partitioned in the right way, and loading takes very long. So you will have to identify this one in the monitoring. And then there is spill, actually, which is once a partition doesn't fit into the memory of one executor, they will actually spill to disk. So they won't keep it, the executor won't keep it in memory. That could be a configuration problem, but probably not. Especially if you don't cache any data, because that takes away a lot of memory on the executor. But spill is something we can monitor as well in the Spark Web UI, for example. It may be the cause of a skewed data set, but there may be other causes as well. For example, as I said, caching data or configuration. What else? Feeling like in school now.
It's okay.
No, I cannot come up with the other 2.
It's okay. I find it funny that still the small files problem, or the small data problem, it has been here since the Hadoop days, and it is still a problem, right?
Yeah.
Using small a lot of small portions of data and processing them.
I mean, so from the projects I've been working on, it's actually such an important decision to make, and you usually have to make it quite early in the project. How do you partition your data on disk? Because actually, you will have to analyze all the use cases you have on the data. And then you have different access patterns. So some only want to see the data of 1 year. Some won't want to see all the data of one customer. Some want to see all the data for one product you offer in the retail store. And you want to find a strategy how you can load only that part of data you want to have. So the layout on disk is actually quite important.
Okay.
Yeah. Yeah, and that's why I put memory management here, because there we will see how the executor manages memory and how spill happens and so on. And yeah. Okay, moving on to part 5, integrating Spark. It's kind of optional. It depends on what you're interested in. That means connecting Spark with other data sources or other technologies which are common in big data platforms. So you, for example, connecting to S3 or HBase or Kafka or what else there would be, HDFS, I don't know. And then running such an application in the cloud or in a Docker setup, whatever. So that would be integrating Spark. And then there's part 6, which is my personal favorite. But it's probably the hardest to learn by yourself, because I would argue that this is where the experience comes in. So once you have 10 years of experience using Spark, you will probably have produced some errors yourself and debugged them, and you will have learned something about them, where they happened and so on. So in the end, you will detect patterns, what is better to do and what not. So that's the experience. And also I like to put here writing high quality code, which for me has actually 2 traits. It's basically that the code is working as expected, so it's functional, and one can change it easily. So you can adjust it later on, because that's the one thing that happens in every project all the time. You will have to change what you've created before. So and that means testing, how to structure the code. Actually, it's the software engineering part. That also goes way beyond notebooks or small analysis, but rather real Spark applications. And also becoming fast, I like to put it here, because I'm a huge fan of using an IDE and using also the shortcuts, being fast, because as developers we are basically editing text all day long. And
It's true.
yeah, it's good if you have some shortcuts there, and that's what I teach there, to do it on yourself or by yourself. I would recommend maybe a good idea, if you're a Scala programmer, you can look at the Spark source code. You will learn a lot how they are structuring the internal code, or look at public and large or popular GitHub repositories of Spark applications and see how they are doing it. That might help at least for how to structure the code. Yeah, and then that's basically the roadmap I follow along.
Yeah. And from that point on, it's just exercise, 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 exercise. Right?
Yeah, exactly. Yeah.
Need to push through the problem solving.
Yeah, I
and
mean
so on.
that's what I find also tough about video courses. So if you do only video courses, usually we are tempting to go too fast. We watching all the videos and never get the hands on. So, but it's actually when you learn, or actually I also like to tell that, I mean, I have a slide later. Becoming pro or becoming really good at something is actually a matter of confidence, in my understanding. And you will get this confidence if you have built something yourself, and have found out something, how to do something on your own, and you have implemented it, and you've written a test, and out of a sudden you feel like, okay, I can basically build anything in Spark, solve some interview questions, whatever, quizzes. But really writing some code will help you also being very confident also in the interview or moving on.
Yeah, I always tell this my students, right? I have prepared, because in my academy everything is prepared, right? They get the data sets, they get the source codes, they go with me step by step. But in the end, they need to what they have learned, take what they have learned, get a different data set, and then just try to do something on their own.
Yeah.
And then the questions come. But unfortunately, too many people are a bit lazy, and they think, I've done the course, now I can code.
Yes, exactly. With my most recent student, we've been working for 3 weeks on a code base as well. And then the next assignment was delete the entire code base, start over, do it all yourself again, implement this and that. So yeah.
Okay, nice. That's cool. What question did one thing I had. So because we were talking about this before, but I think that's also interesting for everybody who's watching. There's always the question, Scala or Python, right? Everybody online talks about Python. People are still using Scala. So what's your opinion on that, and what have you seen over the years as a freelancer out in the wild?
Yeah, many things come to mind actually. What I experienced in the past years was that Scala was way more popular within the companies. Some are coming from Java, so they used to have Java code, and Scala is actually compatible with, I don't know, business rules they have implemented already or whatever. So they have a strict requirement to use Java or Scala, which both are possible. However, recently Python is basically getting everywhere, and also with Databricks. So I see in many job posts and requests also asking for PySpark. Both are very popular at the moment. I personally really enjoy Scala. So if I could choose my language in which I would like to build my own project, I would always use Scala, because I simply also have a strong Java background, and I really like how the language features are. So it's a very concise and elegant language, I would say. Whereas Python, sometimes I really don't like it too much to code with it, because sometimes the auto completions don't work, and the imports don't work. I don't know. So it's not so strictly typed. That's my problem, because I really like the strictness of a typed language. And yeah. However, recently I was following a discussion on LinkedIn, where there were argumentations whether it makes any difference with respect to performance monitoring or internal execution, which API you use with Spark.
Okay. What was the goal, or what was the outcome there? Because people always say like, yeah, Python, that's a toy language for Spark, because you need to use Scala. It's a lot faster than Python, and it's the language that it has been made in, and like.
Exactly.
So what was the outcome of this?
It was very interesting, because actually the discussion started with someone saying, okay, you can write SQL queries, simply the text query, and you hand it to Spark and it will execute it. And actually, I created a poll later on, and I made a video about it. And most of the people were answering that there is a difference between any of the APIs. So if you use SQL or Python or Scala or Java, people thought it would make a difference. But actually, there's no difference at all. I mean, yeah. Because I can give a short explanation, but there's a YouTube video I created on this. It's the API that we were referring to. We only use it to build an internal representation, which is called the logical plan. And the logical plan contains operators and all of the parameters we pass into Spark or we create in the program. And this logical plan is basically completely abstract of the programming language. It only says, okay, we want to join something, we want to filter something, here are the attributes for the filter, and so on. And that will be executed on the cluster. So the language we use or the API we use is simply the, how do you say, a tool to tell Spark what to do.
Okay, interesting. Yeah, I was thinking that back in the old days, there might have been a difference when people were working just with RDDs and there was not really optimization on top of it.
Yeah,
Now
that's for sure.
everything is now Spark does a lot of optimization in the background by itself. So
Exactly. So, yeah. Okay. That's a very important distinction, actually. So I was talking about Spark SQL because the discussion was about SQL.
Okay.
But in RDDs, I cannot give the answer from the top of my head, actually.
It's not important.
I don't even know if there are multiple APIs for RDDs or if it's only Scala.
That's a good question. No, you can use Java. Because I started with RDDs in Java, then I use Scala.
Don't know if there's a Python.
Wow,
there's for sure no SQL.
We're some sort of experts here.
Yeah. I mean, who uses RDDs?
That's true. All right. Yeah, that video, and maybe everybody, if you want to check out that video, Philip also has YouTube channel, and that is under your name, right? It's just It's just your name, so it's easy. It should be easy to find. Shall we go through a few questions, Philip?
Yeah, sure.
Let's
see. Hope I can answer them.
We're going to figure it out. What's here? Let's see if we can. Spark is widely used, but as new solutions emerge like Beam, what do you think is Spark going in the near future? Will it continue to be a high demand tool in the big data ecosystem?
Yeah, I mean, probably it's the same answer as before. So I would argue many companies already have made or have adopted Spark. And we have to think about companies which are not as fast as adopting technologies as the developers.
That's true.
So basically exchanging a technology in a company is a matter of millions of dollars. So they have code bases, everything has been implemented, all the pipelines have been set up. Now that we have seen that so many companies are moving there, this trend will be continuing. Yeah. So some companies like to use AWS. Then you have probably kind of a vendor lock-in there. However, there are many companies not moving to the cloud because they have their on-premise solutions as well. I think it's best to pick one technology which is important now and learn it to a very high level. And then the transition will be very fast. So I've been working with Snowflake the other day. I think they have basically recreated the Spark API in their Snowpark, and everything is quite the same. So it's a wrapper around it. I don't know why exactly they're doing that, but once you know Spark, you can adopt this within no time, actually.
I haven't used Snowpark. But as I have heard a few months ago, it's basically they wanted to rebrand or shift the use of Snowflake. Yeah. Because Snowflake was like which analytical data store, which data warehousing solution are you going to use? Something like Redshift, BigQuery, Snowflake. And then they came in Databricks and they were doing the same thing and processing on top of it.
Yeah.
Right. And so their goal was to shift more towards becoming another Databricks and becoming a bigger competitor for Databricks.
I see.
And not just being a warehousing solution.
Yeah, exactly.
But
And then, I mean that's also a very good example for the answer I've given before. So Spark, you can adopt it in all these technologies, because at the foundation you cannot do it so much different than Spark is implemented at the moment. So yeah.
One that I liked here was what advancement are being made in the area of machine learning and AI within Apache Spark ecosystem? How do these advancements fit into the broader roadmap for the project? Because there were a few things a few years ago, right, for Spark ML stuff, but it never really took off.
Yeah.
So is there something right now where people like really using it for?
So from what I know, I'm not so deeply in the ML space, but there are some algorithms implemented in Spark ML. I used to work with them years ago, but in the end, the real machine learning frameworks have different names. So PyTorch or scikit-learn. So there you have all of the flexibility. What I noticed when I back then when I worked with Spark ML, they were implementing all of these algorithms again in Spark machine learning, but there's always a lag. So there's a new algorithm and it takes a year or whatever until it is in Spark ML. And also you don't have so much flexibility because you're behind this API in the end. Where I see the synergy between Spark and ML is basically the entire data pre-processing. So probably the models will be trained and built in different technologies. But as I said, that's only what I have experienced, and I'm not very deeply in these topics.
Where are some more questions? There was more of a statement, but that leads into a question. It's good to follow some books like Cracking the Coding Interview to achieve a better performance. High quality code as part 6 of the roadmap. It's good, or is it good?
Probably is it good?
Yeah. So are there some books that you also recommend to as a
I really enjoy. So for part 6, where I said high quality code, I can recommend Clean Code, which I read myself, and it was very, very helpful. It's actually something every developer should read. Everyone writing code should read. From the other ones, the other ones mentioned, I don't really know. What was it? Cracking the Code Interview. I haven't read it. For performance, I really would encourage you to study internals. And to be honest, I haven't found any book which explains internals well. So I've read, and when I was learning Spark, I read some books about Spark, but they were doing more like high-level statements there, saying that, for example, Spark SQL builds on top of Spark Core, but there was no detailed explanation which would allow you to understand how that would be.
Actually, isn't no, I closed it. Isn't there this book here? Let me share my screen for everybody. Share screen. Like, I remember when I started with this, I used this book from O'Reilly. But that was, for me back then, that was more of an introduction, like how did the internals work and how to get started, and with some figuring out a few problems. But that's like 2015. I don't know if this is still a thing, this book.
Yeah.
Have you used that before?
No, it's been a different one.
Okay.
Yeah. I don't know that one, so I can't tell anything about it.
Yeah, because for me, books were always, I wasn't a book learner, right? I learned by doing, and then when I felt like I hit a wall and I couldn't get further, then I would get the book on the tool and try to find if there's a solution in that book for my problems.
Yeah.
So for me, I can only tell for me, I always learn by doing, like with your program.
Yeah, for me was actually how I got into content creation was that I wanted to understand something, and then I studied or researched it, like the topic, and then in the end I was creating a piece of content. And that I would argue is that's my way of learning. So if I don't understand anything, I try to start from a very specific question. So for example, how do filter pushdowns happen in Parquet file format? And then you can read some stuff on that question, and you will experience a lot of how the internals work along the way, probably. But what's working best for me, actually. So going through a book, then it's not specifically tailored towards the question you have, but rather it's okay. You learn again what the components of Spark are, and that there are 4 APIs, and so on.
Okay, Philip, let's wrap up for today. Let me quickly open something. Where is your event? So I want to show people here's your LinkedIn profile. Let me see. Can I just copy this in here in the chat? I think the chat only works on YouTube. So I copied this into YouTube. There people should find your event for later. Events, live coding. Yeah, just click here and then you get to the live coding that happens in 1 hour, 15 minutes. And if people are interested in getting coaching from you, they can go here, learndataengineering.com, and I have you here in the live training and monitoring and mentoring part with other students from the Turbo Mentors program here. And here's actually the link to Philip's Academy, to Philip's coaching. Somebody asked here, is there a online course for PySpark? A quick introduction I have in the Academy. I have in the all courses. I have a course on introduction to or the Spark fundamentals with PySpark. Yeah, Philip, thanks for joining.
It's been fun.
It's been a lot of fun. It's also very nice to talk to somebody who also likes Spark and who has experience working with Spark. I hope that people are going to join. Many people are going to join the live coding. I know people like this. And yeah, we talk soon.
Yeah.
And everybody, thanks for joining. Thanks for all the awesome questions. And if you have more questions, get in touch with Philip. And if you are searching for one-on-one coaching, Philip is the guy to do it. And then, yeah.
Thanks, everybody. Thank you, Andreas.